Titans. Hello and welcome to Chapter 7, Section 3. We decided to start that lesson off with a little Bon Jovi. We'll also dedicate this teaching video to the one and only Coach Dan Hogan. Coach Hogan is the top-ranked PE teacher in the state, so a shout out to him, and we'll go ahead and dedicate our teaching to him on this video. Titans, hello and welcome to Chapter 7, Section 3, the elimination method. As you can see, you're going to need your sunglasses and your leather jacket for tomorrow because it is time to play the role of the Terminator. We are going to terminate, or in other words, eliminate the variable. So, hasta la vista variable. In Chapter 7, Section 3, our objective is to use the elimination method to solve a system of equations. The question often comes up, why do we need another method? Well, the more ways the better. Another method for solving a system of equations in which the equations are added, or in other words combined, to eliminate, or in other words terminate, one of the variables, is the elimination method. It is especially useful when both equations are written in standard form. So let's go ahead and dive into the steps of the elimination method. Step 1 is to multiply one or both of the equations so that when you add the two equations together, one of the variables will be eliminated. This step may not always need to be done. Step 2, add the two equations together so that elimination occurs. After adding the two equations together, you'll be left with one variable. You need to then solve that remaining one variable equation. Then your fourth step is to go ahead and substitute that value you found back into either one of the original equations, and then solve for the other variable. After that, you will have an x value and a y value, and you can complete step 5 by writing the ordered pair. Now that we have the steps down, let's go ahead and complete an example. Let's solve this example by the elimination method. So as you can see, we have the example of 3x minus 5y equals negative 16, and 2x plus 5y equals 31. So to solve this by the elimination method, we're going to go ahead and look to see if we need to do step 1. Step 1 is to multiply one or both of the equations so that when we add them together, elimination will occur. Now as you can see, we can skip this step because we have a negative 5y and a positive 5y. So when we add these two equations together, the y's are going to be eliminated. So we can skip step 1 and go straight to step 2, which is to add the two equations together. When we add the two equations together, we're left with 3x plus 2x is 5x, and then the negative 5y and the positive 5y, those eliminate, or in other words, they terminate. So all we're left with is 5x equals 15. Then we would divide both sides by 5, and we would get an x value of 3. Now, the next step is to go ahead and take this x value of 3 and plug it back into either one of the original equations. Which one you choose is totally up to you. For this example, we're going to go ahead and plug it back into the first equation. So, since we know x is 3, we can take x out and plug in 3. We'll then have 3 times 3 minus 5y equals negative 16. 3 times 3 is 9, so we'd have 9 minus 5y equals negative 16. We then get rid of that 9 by subtracting it from each side, and then we finish the problem off by dividing both sides by a negative 5. That leaves us with a y value of positive 5. So now we have an x value and a y value, so we have our solution. And our solution is the ordered pair 3, 5. Alright, let's go ahead and look at a second example. Okay, now if you look at this example, once again, take a look at it. If we add these two equations together, will one of the two variables be eliminated? And the answer to that is yes. So once again, we can skip step 1 and go ahead and just add these two equations together. When we add these two equations together, the x's are eliminated. And what we're left with is 6y equals 30. We could then divide both sides by 6, and we have our first value, which is y equals 5. We then take y equals 5 and plug it back into one of the two original equations. Once again, which one you choose is totally up to you. We'll go ahead and choose the first one. So when we plug in 5, we have x plus 2 times 5 equals 18. 2 times 5 is 10. Then we subtract 10 from both sides, and our x value is 8. When you have an x value and you have a y value, you then have an ordered pair solution. So our solution is 8, 5. Alright, we'll go ahead and finish up our lesson today by going over the second type of problem. And that is the type of system in which you must multiply one of the equations in order to eliminate a variable. So Titans, keep in mind, sometimes the setup of the problem will require an extra step in which you must multiply one, or possibly both, of the equations by some number so that adding eliminates one of the variables. So let's go ahead and look at our third example of the day today. Now notice, students, when you add these two equations together, the variables won't be eliminated. 4x plus 5x is 9x. 2y plus 6y is 8y. And that is not what we want. We want one of the variables to be eliminated. That's why they call it the elimination method. So what we need to do is eliminate the x's or eliminate the y's. In this situation, we're going to choose the y's because it would be pretty easy to make 2y and 6y become opposites. If we could make 2y become a negative 6y, then the y's would cross out. So think, how can you make 2y become negative 6y? Well, if you take 2 times negative 3, you'll get negative 6. So what we do is we multiply the entire top equation by a negative 3. When we multiply the entire top equation by a negative 3, that leaves that top equation to become negative 12x minus 6y equals negative 24. Now, if you notice, we can cross out the y's. They're now opposites. Negative 12x plus 5x is negative 7x. Negative 24 plus 3 is negative 21. So we have an x value of 3. Once again, we couldn't just immediately add the two equations together because it would not have eliminated a variable. So in order to eliminate a variable, I multiplied the top equation by negative 3. That made the 2y become negative 6y, and then it allowed me to eliminate by addition. Once I have my x value of 3, I go ahead and I plug it back into either one of the original equations. It doesn't matter. For this one, I'm going to choose the bottom equation. So I plug in 3 for x, and then I solve that equation, and I have my y. Alright, Titans, that concludes lesson 7.3, part 1. Please make sure you fill out the Google form that is on the blog spot below this video. It is recommended that you try question number 11 on page 335. The answer to that question is 2.5, 1. See if you can solve the question by elimination and get that answer. It would be a great practice example after going through this lesson. Know that you can always pause this lesson and rewind. If we go too fast for you, rewind and rewatch it. As we said in class, kind of our goal is to keep these videos around 10 minutes. So at times, if we go too fast, please make sure you use the stop button, rewind, do what you need to do to make sure you get the information. Alright, Titans, thanks for your time. Hope you have a great evening.
Made with Doodlecast Pro.